The other way that we're inducing neuroplastic change is through skill-based exercises. So we have a database of over 1,000 individual exercises and activities. They're divided into 9 skill categories. And you can see here breathing, balance, core strength, hand-eye coordination, crossing the midline, body coordination, dexterity, flexibility, aerobic endurance. All of these actually activate, of course, overlapping, but also slightly different cortical systems. So for example, we talked about hemispheric asymmetry. Sometimes that comes from a developmental phase where interhemispheric communication is atypical. And so when we do exercises like crossing the midline, you are retraining almost in that developmental stage. And so depending on the needs of each child, obviously, we are targeting their skill needs. Why do we also use skill-based exercises? So kinesthetic learning means learning by doing. When we talk about neurodivergent populations, training just by talking doesn't work, but we know that training by doing becomes much more effective. At the same time, it is activating their motor system as well as their interoception system. It also contains elements of sensory integration, training body awareness. And when we talk about especially aerobic endurance, we increase dopamine regulation in the frontal striatal circuitry. We know that this is extremely, extremely effective, especially for attention training, as well as neurotrophic factors for upregulation. So we're increasing the propensity for plastic change in the brain. To give you a training session summary, each HFS session is around 1 hour. Sometimes it stretches to 90 minutes. And it contains music listening therapy for 1 hour to 1.5 hours. Simultaneously, children are being led by the HFS coach to do a skill-based exercise training. So there are 6 different exercises per hour. And we have a debrief in the last 10 minutes of flow activity. The flow activity is really like a free-flowing, almost like a dynamic mindfulness activity. And this is for them to integrate and be able to voice what they want to do. So sometimes children do drawing, sometimes they choose Play-Doh, sometimes they want to sing, sometimes they want to chat even. But it's a chance for children who come into our centers who are already being told at every moment of every day what they have to do. And we really want to give them a period of time to just have ownership over what they want to do. And so this is the main structure of the 1 hour session. In terms of the AI handling, our initial inputs come from something we call the Fundamental Ability Survey, or the FAS scores. It is derived from the 5 to 15 parent rating score. It has 13 subscales of different cognitive and behavioral skills with 148 total questions. The scoring ranges from 0 to 2, with 2 being the skills are more poorly rated. And scoring is based on the normative data that's age and sex stratified. And when we have these inputs, our system helps us to optimize 2 things in the beginning of the entire intervention design, which is the music module optimization. So we have 6 different music listening therapy modules. Each have different frequency filtering profiles. And so this is what the AI handling, one of them, tries to optimize for us, or does optimize for us. The second is the skill-based exercise category weighting. So I mentioned we have 9 categories. AI helps us with the category weighting, so the proportion of which skill needs to be focused on more. And it helps us with the starting baseline difficulty. And then we have per session inputs as the intervention goes on. So the AI handling for input is the HFS coach feedback. Again, we never leave any of the decisions just only to the technology, only to an AI system. We're consistently feeding in human observation as well. HFS, the coach feedback scores are based on per skill-based exercise scored on multiple dimensions, from engagement to physical ability. So combining that with parent feedback scores, that is the per session input, and then per session output, the AI optimization is on the skill-based exercise. So again, adjusting for engagement, suitability, attainability. This is what the child sees, the children see. So they see a breakdown of what are the different top 3 skills that they want to build. And here we see the category weighting. So this is the interface that we show our clients and their parents using our management system. So to end, I want to give you a sneak peek of our pilot intervention data that's derived from our California sensors. We took a sample of 58 clients, 58 children with mixed diagnoses. So this is a breakdown of the different diagnoses that we see and male-female distribution. 58 total number of US clients for this sample, trained total of 1,895 hours and a mean age of 9.3 years old. And you can see that some of our children and their parents, they are really, really committed. They commit to over 100 hours before even beginning the therapy, the intervention. And again, I want to emphasize that our attrition rate has been 0 so far. This is a pre-post intervention comparison of the FAS parent rating scores. And we see that in every single dimension, there is a decrease trend. And in over half of the dimensions, we have a significant difference, significant improvement. And this is after an average of 40 HFS sessions. So we see behavioral skills and cognitive skills in emotion, attention, impulsivity, concept of time, planning and organization, language, and comprehension, expression. You see these improvements. We also tested the before and after intervention effects using something called the VCAT, which stands for the Virtual Classroom Attention Test. This is another solution that Cognitive Leap uses, and it's actually an FDA grade diagnostic aid for ADHD and related assessments. So this is very well published, but I'm not going to go into too much detail on this product because I want to use it as an example of how we're objectively tracking attention data in terms of cognitive attention and motor attentions. And so it has a CPT performance test and a 13-minute VR assessment. We have environmental distractors, and the user sits in a VR environment and does a task in a virtual classroom. And so we're tracking their motion data in 3D space throughout this assessment. It's very sensitive to subconscious attention-related performance in real time, and it doesn't rely on subjective third-party observation. And so what we see is that in every single VCAT variable, we see improvements after an average of 50 HFS sessions. In terms of attention errors, we see highly significant decreases. In terms of focus and accuracy, we see highly significant increases. And when we look at the motor measures of attention, so physical impulsivity and physical stillness, we also see significant improvements in all of the variables. So these are extremely, extremely hopeful and very positive results that we're very proud of. It really helps us reinforce that the human-centered design of our intervention is highly effective. We also see correlations in the different scores. So between the different scores of the FAS, so what this is showing is it points back to the interrelated cortical networks that we see that are divergent in autism, because the improvements of certain skills correlate with improvements of other skills. We also see correlations between the subjective and the objective measures.